Hey everyone, welcome back to Tech Hub. It's been a while. I'm gonna be doing this video in English because I feel like it, and maybe I hope I could reach the international audience and make that YouTube money. Anyways, I would like to be talking about hashing today. Sorry for the poor production quality, but that's all I've got. So, hashing, I've been thinking about that for the past few days, and it's quite an interesting concept, so I would like to share it with you all. So, some of you might have known it already, and some of you might not. So, this video is going to be split into two portions. The first portion is going to be the theory portion, and the second portion is going to be the practical. So in the theory portion, I'm just gonna give you all a high-level, top-down approach and explanation of what hashing is, what it does, what it can do, and how do we apply it in real-world applications. And in the second portion, which is interesting, and you can follow along as well at home or wherever you are, if you have access to a computer, any form of computer, and a Python interpreter, because I'm gonna be using a Python, obviously. I'm gonna be coding up a simple Python program to demonstrate some of the key aspects that I've discussed in the theory portion. Alright, so let's begin. Alright, so in the theory portion, I would like to start by discussing what hashing is. So hashing is essentially a one-way process, right? So any point in the future, if people start talking about hashing, just remember it is a one-way process. One way. So, what hashing essentially does, right, it takes an input, passes it into a hash function. HF stands for hash function, and it returns an output, right? And generally, that's what functions do. Functions accept input and returns an output. Yeah, and by the way, I'm going to be doing this video in the software engineering aspect, so please don't quote me on like the intricate details, because I just care about what it can do and what I can do with it. Anyways, moving on. So the hashing is a one-way process whereby an input is passed into a hash function, and it computes and it returns an output. And this output can also be called the hash, or the hash value, hash code, digest, and many more. The terminology doesn't really matter. What matters is that input, hash function, output. And the reason we call it one-way process, it is because we are not able to reverse this process, meaning input hash function output, but we can never go output hash function input, meaning we will never be able, I wouldn't say will never be, because some hash functions, the weak ones, they got cracked by brute force. So we are theoretically unable to recompute and regenerate the input from the hash. We can only compute the hash from the input. So just by having the hash, we will never know what the input is. Right? This is an interesting concept. Right? So this process is irreversible, meaning an input can create an output, but we can never get back the input just by knowing the output, and we cannot plug the output back into the hash function to produce the input. So it is irreversible, therefore we call it a one-way process, right? One-way process because input hash function output, we cannot get back the input from the output, because that's how hashing works. Now, another key factor that we have to remember is that hashing, right, it will always consistently generate the same output for the same input, right? No matter how long apart you plug in the same input into the hash function, it will always create or it will always compute the same hash or the same output, right? So for example, if this hash function is kept consistent, if I input I, gives me an O. If I input A, gives me an X. If I input B, it will give me a Q. This is arbitrary. This is an example, meaning that there is no way that if I put in I and suddenly it gives me a Q, or there is no way that I put in a B and it gives me an O, because if this hash function is kept consistent, then B will always give me Q, A will always give me X, and I will always give me O. Based on these two facts, we can conclude that by using hashing, we can consistently generate the same output for the same input, and this process is irreversible. These are the two main qualities of hashing. So now, what can we do with it? Firstly, storing passwords in the database, right? When we store things in databases can be hacked, and when our databases get hacked, we don't want the user's confidential critical data to be leaked, and the passwords are in plain text. For example, if you are a programmer and if you store the user passwords in plain text, you shouldn't. You shouldn't do it. So instead, what you should do is compute the hash of the passwords before you store them, and then insert into the database. Right? By doing this, in the event that the database does get hacked and the user data get leaked and released into the wild, at least the true passwords that the users use are not out in the open, right? They are only the computed hash of the password. So instead of the actual password, it's just some computed hash computed by passing the password into some hash function. And we know that since it is irreversible, although the hackers may have the hash, they will be unable to recompute and regenerate the actual password. That's the beauty of hashing. So always remember, storing passwords in database, when you are going to do it, you compute the hash of the password and then you store them. Never store passwords in plain text. And the second application, and this is what I find the most interesting, it is used to verify the data integrity, and we can use it to make sure that the data is uncorrupted. Let's say if you have a file, a perfect file, you've just created it, you just compiled, generated, beautiful. And you want to make sure that when you send it to someone else, across the network, across the internet, you want to make sure that that file and the file that your recipient gets on their end is the same. It's consistent. It's uncorrupted during transit. Right? What do? First, you get your file, right? And the file, any file, if you think about it, is essentially just a bunch of bytes, right? A bunch of just ones and zeros, or in hexadecimal values, right? Essentially, they're just bytes. Think about them as bytes. A lot of bytes. And what you can do is you pass those bytes into the hash function and create or compute the hash of the file. So we would have essentially, if we carry this out, we would have the main file plus the hash, and we would call it the checksum. of the file. Okay, so we have our file, our beautiful file, and we compute the checksum by passing the file into the hash function, and we compute the checksum. Now, what we do is that when we send it over, we also send the checksum, or the recipient is also made aware of the checksum. So, when the recipient receives the file, all the person or all the recipient have to do is plug in the received file into the same hash function, and if it produces the same checksum that is sent by the sender, then they can be absolutely sure that the file is uncorrupted, right? Because here, consistently generating the same output for the same input. So if the file, aka the input, is the same, and then so therefore the output, aka the checksum, must be the same. So if it's the same file, it will produce the same checksum. But if due to any reason or unfortunate events, the file gets corrupted, a bit flipped, blah blah blah, what happens is the input, the file, will generate a totally different checksum. And if the checksum don't match, then we can be sure that the file gets corrupted. So if the file were to be corrupted, the computed hash or the checksum changes, and it does not match the original checksum anymore.